Today's news is full of the wild, the weird, and well, the kind of awesome. First, we have a Black Widow binary.
Then there's a robot learning to taste food.
And our middle section today is brought to you by the letter S with solar cells, solar flares, sonification, and comets.
That last one was a bit of a reach. Finally, I'll talk about occultations in this week's What's Up.
All of this and more right here on the Daily Space. I'm your host, Dr. Pamela Gay.
And I'm your host, Eric Mattis.
And we're here to put science in your brain. Folks, it is a star-eat-star world out there. Earlier this week, we mentioned a supernova explosion that came about from a star having its atmosphere eaten off. Now, we have news from MIT of another star system that includes a tiny, dense pulsar that is pulling material off its nearest companion, while a third star shines on from a safe distance. The two inner stars circle in a deadly tango every 62 minutes, while the outer object goes around every 10,000 years. Cataloged as ZTF J1406 plus 1222 and classified as a Black Widow binary, the inner pulsar is sustaining its high-speed spin by stealing rotation from its mate. Normally, pulsars slow down over time, but Black Widows instead devour mass and with it angular momentum from their companion stars, allowing them to look younger than they are and to stay young looking longer. This really is the stuff of a horror novel. The roughly 1 hour orbit of the pulsar and its dying mate is the shortest orbital period so far observed for this kind of a system. It also varies in optical brightness in a novel way. The pair appears to dim and fade by a factor of 13. This can't be explained just as one star blocking the light from the other and then allowing it to be seen again. Instead, it appears that the larger sized and lower mass companion is being heated up by the pulsar and locked in a death grip. As the two orbit, the heated side of the companion comes in and out of view, and that heated side is just brighter. It is like it is screaming out in light to point out where it is being destroyed. Have I mentioned astronomers like to anthropomorphize things? The universe is a violent place, and nothing is safe from the pull of gravity and the blast of light. Black widows abound, and the stellar variety are amazing in their destruction. This work appears in the journal Nature and is led by Kevin Burge.
From tracking stars, let's now turn to tracking spacecraft. The current system for determining a spacecraft's attitude in space requires several radio transmitters on the ground and star trackers on the spacecraft. The problem with this method is that the radio transmitters need to be used for other things as well, and star trackers can wear out. Researchers from the University of Illinois Urbana-Champaign propose a new method, and it uses pulsars. This method uses basic triangulation to determine the spacecraft's rough location to within a few astronomical units, and a special algorithm narrows down that range by carefully looking at the unique signatures of different pulsars. The team analyzed signatures of over 2,000 pulsars to generate this algorithm. This new method promises to increase spacecraft self-sufficiency by allowing it to determine its position with no outside information. Spacecraft autonomy is becoming more and more advanced. This work was published in the IEEE journal Transactions on Aerospace and Electronic Systems.
Sometimes a press release comes across the newsfeed that makes us stop, stare, giggle, and decide we have to share it with all of you. This is one of those stories. Researchers at the University of Cambridge have been working with appliance manufacturer Beko to train a robot chef to taste food. But it's not just about tasting food. No, they're training the robot to keep tasting the food as it mashes it up, simulating how the taste changes as you chew. The results were published in the journal Frontiers in Robotics and AI and are hoped to help aid in the development of automated food prep. After all, you want your robot chef to be a decent chef, and since human chefs taste as they go, it made sense to do the same with a robot chef. However, first you have to train the robot to know what is pleasing to the human palate. In this particular research, the team focused on the saltiness of the dish prepared: scrambled eggs and tomatoes. According to the press release, the robot, quote, tasted 9 different variations of scrambled eggs and tomatoes at 3 different stages of the chewing process and produced taste maps of the different dishes, end quote. As for how the robot tasted the food, that involved a conductance probe attached to the robot's arm. The probe then acts as a salinity sensor, which the robot moves in a grid pattern to make different tastes of the dish. Not surprisingly, this new method helped improve the robot's ability to assess the saltiness of the dish against the previous method, which just tested a single sample one time. Don't go expecting to buy your Star Trek-style food replicator anytime soon, though. These robot chefs still need to figure out other flavors like sweet and oily. Coming up next, we have solar power, solar flares, sonification, and the shape of cometary dust. Stay tuned. Satellites and other spacecraft, landers, and rovers are often powered by solar cells. Capable of working for years without replacement, this is a proven technology. But solar cells are also a technology that can be improved. Over time, solar panels degrade in the harsh space environment where they are plagued by radiation. Here on Earth, researchers are constantly trying to find new, more rugged, efficient, construction-friendly designs to integrate into a clean power future. And it turns out, a new design of solar panel, perovskites, that suffer on Earth may be perfect for space. Researcher Ian Sellers explains, quote, perovskites are exciting to a lot of people in the photovoltaics community because this new solar cell material can reach high efficiencies and has done so quickly and relatively simply. But these materials also have significant issues in terms of stability and yield, particularly in atmospheric conditions. Moisture, oxygen degrades this material. So it was interesting that there were a few people who suggested that despite these terrestrial instability issues, this system appeared radiation hard and appropriate for space, end quote. To test this possibility, the environment of space needs to be brought to Earth, or at least simulated in a lab. A new paper in Joule that is led by Ahmad Kamarni details what kinds of conditions need simulated with this novel solar technology. And I mean novel. Sellers goes on to explain, quote, these perovskites are very close to being a liquid, so when they're damaged, they self-heal. Perovskites, like a tub of water, will be disordered and damaged in space, but will also very quickly settle or heal and go back to normal. What we've done is to create a protocol, a set of conditions that perovskite cells must be tested at before they go into space, so that the global community is testing these materials properly and in the same way, end quote. Solar cells are the future. They may be weird. They will certainly be wonderful. I can't wait to see them come into being. All this research into solar power and solar cells is coming at a time when the sun itself is amping up the energy. It seems like every few days we get another bulletin about a solar flare, and this week is no exception. On May 3, NASA's Solar Dynamics Orbiter caught a moderately sized flare that has since been classified as an M-class flare. M-class flares are not the most intense flares. Those are the X-class flares. But they are fairly common when the sun is active. In fact, there was another M-class flare just yesterday, May 4th, which was also imaged by the Solar Dynamics Orbiter. But wait, there's more. Also on May 3, there was an X-class flare. According to NOAA's Space Weather Prediction Center, quote, high-frequency communications may have been prone to contact loss over the Atlantic Ocean and portions of eastern South America, Western Africa, and Europe, end quote. And there was even another X-class flare observed on April 30th. Talk about heading into solar maximum. As a reminder, these flares are not directly harmful to people on Earth, but they do pose a risk to astronauts and spacecraft. They can also impact our power grid and navigation systems, which could definitely cause trouble for humans. On the other hand, powerful flares can make for some pretty awesome aurora. And if you have a telescope set up for safe solar observations, you can even take a look at all the sunspots causing the solar flares. But remember, never look directly at the sun without proper safety gear. If you are set up for solar astrophotography, please share your sunspot images with us on Twitter, as we do love your pretty pictures.
Astronomy is not all about pretty pictures, because some people can't see them. The process of turning pictures to sound, or sonification, has been around since the 1970s. Researchers first applied this technique to the area around the supermassive black hole Sagittarius A star in 2020, and have expanded it to other areas in later years. The latest Chandra X-ray Observatory project, the fifth in the series, involves actual sound waves for the first time. Space is generally not dense enough for sound to travel, but the center of galaxies, such as the Perseus galaxy cluster, has enough material for sound waves to travel through, and these are recorded in the new sonification. However, the sound waves are very faint, so to produce something audible by a human, the data was boosted by almost 60 octaves, 288 quadrillion times louder than the original. That's 28 with 15 zeros. The sound is plotted radially to show that the cluster's gas extends different amounts in different directions. I've listened to it, and my impression is that it's spooky. Beth agreed, and also said that it sounded like a deep whale song, mixed with zooming race cars. We'll have a link to the recording in the show notes for today's episodes at our website, dailyspace.org. Another sonification released by the team is of the famous black hole in Messier 87. This one includes 3 different tracks showing how the object looks in X-ray, visible, and radio light. For this sonification, instead of actual sound waves, quote, each wavelength is mapped to audible tones. One can hear and see as the sonification is accompanied with a picture of each wavelength and a waveform, the differences in the intensity of light produced by the different wavelengths in this object. I found this one more pleasant to listen to, but it is more processed compared to the Perseus one.
We haven't quite gotten to the What's Up segment just yet, but this next story is about something that you can see in the night sky, if you have a big enough telescope. A team of scientists in Finland have been tracking the orbits of particles coming off of Comet 17P Holmes since 2013. They have found that these particles trace out an hourglass shape, with the north and south sides of the cometary tail collecting particles in what they call nodes. These nodes give some insight into how the comet evolved. Back in 2007, the comet got significantly brighter and its core expanded, shedding more particles in what is called a cometary outburst. By understanding the paths these particles have taken, the team can plot their way back to where that original outburst occurred in the comet's orbit. And this new research can help scientists predict the location and intensity of meteor showers. Maria Gritsevich, project leader, concludes, We predict that with our published data on the time of arrival and corresponding coordinates of the dust trail of the comet 17P Holmes in 2022, it will be visible even in the telescopes of amateur astronomers. We expect that the results of their observations will provide additional information about the number and size of particles and their geospatial distribution. This information will be useful for developing new models and understanding what happens to the comet and its tail. Next, the team plans to focus on the reasons for the sudden outburst and increase in brightness, as well as simulate an outburst and observe the results. Coming up next, Eric brings us that What's Up segment and explains occultations. Stay tuned.
This week in What's Up is an astronomy phenomenon called an occultation. To put it simply, an occultation is when some object passes in front of another, such as a background star, from the point of view of the observer. This method has been used in astronomy for a long time, mainly to refine the orbits of different planets and asteroids. You can actually see occultations for yourself with a telescope or binoculars. Another way to use occultations for science is to explore the atmospheres of planets, such as what astronomers did with Pluto. A stellar occultation proved that Pluto had an atmosphere in 1988. This discovery was made with the Kuiper Airborne Observatory. Additionally, the New Horizons spacecraft planned to pass by Pluto when its atmosphere was most active, and it did in 2014, capturing images of the atmosphere during the spacecraft's flyby. Scientists used later occultations to monitor the atmosphere of Pluto as it shrunk, and some citizen scientists even contributed. Pluto passing in front of a star allowed the atmosphere to be separated from the planet and also allowed for a better solution to its orbit by timing how long the star's light was blocked and doing some math. Telescopes from the soon-to-be-retired SOFIA infrared telescope in its 747 to the commercial unistellar EV scope were used to observe different occultations. These observations were done in 2011, 2016, and 2018. SOFIA observed an occultation in 2011, and it was challenging because the orbit prediction was not completed until 2 hours before the airplane took off, which required changing the flight plan. SOFIA was designed to track an event such as occultations that move over the surface of the Earth at a relatively fast speed, allowing for more observation time. The team on the next occultation I'll talk about only gathered data for 10 seconds. That team from the SETI Institute used a unistellar EV scope along with a much bigger 14-inch Schmidt-Cassegrain telescope in California to observe the 2018 occultation. They were joined by other teams in North America using equipment provided by a French observatory. All of the telescopes combined to produce data on Pluto's atmosphere. The EV scope has even been used for more citizen science since then. Now about viewing an occultation for yourself. There are several you can view in the month of May 2022 using a backyard telescope. One has already happened. Ceres was a tenth of a degree from the moon on May 1st. On May 19th at 0800 UTC, Vesta will be within 7/10 of a degree of the moon. On May 2nd at 1800 UTC, Mars will be within 9/10 of a degree from the moon. And on May 24th, Uranus will be within 5/100th of a degree from the moon at 2200 UTC. All of these events would be true occultations where the moon covers these different objects if the observer was anywhere on Earth but North America. However, they are still worth seeing because they will get super close to the moon. Another type of occultation is a transit, where an object passes in front of another but does not completely cover it. A transit, you can see regularly, is the passing of the 4 Galilean moons, Io, Callisto, Ganymede, and Europa, in front of the disk of Jupiter. These transits are best viewed in a small telescope, but can be seen in binoculars. And they happen often enough that there may be several during the night where you are. We recommend the Shallow Sky website to see when transits are happening, and we'll have a link to their Jupiter page in our show notes for this episode. Next week, you can also look forward to the moon, which will be at perigee on May 14th. making its angular size a few percent bigger and causing larger tides. Remember, go outside and look up, weather permitting, of course. This has been the Daily Space.
You can find more information on all our stories, including images, at dailyspace.org. As always, we're here thanks to the donations of people like you. If you like our content, please consider joining our Patreon at patreon.com/CosmoQuestX.